Alrighty, folks, let's hop to it. We are going to continue working on comparing fractions, specifically focusing on comparing fractions when they have the same numerator. So the denominator will be different. That is the size of the piece, but there are the same number of pieces, but the pieces are different sizes in the fractions that we are comparing, okay? So we are going to take a look at these today. I would like to review with you, refresh your memory, that we are working with a standard that breaks down into multiple parts. You guys have already worked on comparing fractions with the same denominator. Now we're looking at comparing fractions with the same numerator. We're going to continue on with that 3.3 of justifying our conclusions based on the same, or based on the results of the comparison. Okay, so justifying using math vocabulary. Our assignment today does require us to do parts of the assignment together. And so I would ask for you to click on the activities light bulb to refresh your feed. What we're going to work on today is looking at comparing fractions with the same numerator using different models, using a circle model, a rectangle model, and a number line, okay? Our directions say review the success criteria, watch the teaching videos, and complete the with your teacher slides on 3 through 8. Review the directions for your independent work. So slides 3 through 8 will be us, and then we'll talk about the independent when we get there. All righty. This is our success criteria. We've already reviewed this. If you'd like to review it later on your own time to get yourself back in the zone, that is fine. Take a look at slide 2. When we compare fractions, we have to make sure the whole is the same size. Why must we make sure the whole is the same size? Why is it not fair to compare a large cookie to a bite-sized cookie? Why must we make sure the whole is the same size? 11, why?
Because it's smaller.
And why would that matter?
Because you would get itty-bitty pieces compared to the other person.
Yes. So even if the fraction was the same, like let's say you had 1/2 of a cookie, and then let's say I gave your best friend 1/2 of that cookie, right? Is that fair? You both get a half, but is that the same amount? No. So we got to make sure that the wholes are the same size before we start comparing, okay? All right, let's take a look at slide 3. Slide 3 shows you how to solve a circle model fraction, okay? Circle model fractions. This is a video of instruction, and this is also going to be helpful to you with the justification. There's going to be a lot of math vocabulary in this. Then we will solve slide 4 together. Please do not work ahead. The reason we are going over this is because we are still struggling to complete this correctly. Okay, and some of you, my friends, are already working ahead. I can see it on your screen. Don't make me call you out. My friends who are working ahead are the ones who tend to be not following this correctly in your independent work and getting it back. So please chill. Okay, chill, chill, chill. All right, I will play this video for you. Please watch and listen. And here we go.
In this example, we will compare 1/4 and 1/8 using a circle model. I have already partitioned these models into equal areas or equal parts. On the left, I will represent the first fraction given. I see that there are 4 equal parts, so I will label each part with the unit fraction. The unit fraction always has a numerator of 1. Perfect. On the right model, I will partition and I will label with the unit fraction of the given fraction on the right. I see I'm partitioning into 8, so each fraction piece, each part will be labeled with the unit fraction. After I label each part with the unit fraction, I can now shade my models to represent the given fraction. On the left, I'm comparing 1/4. I'm representing 1/4. So I will shade in one piece of the 4 pieces, or one part of the 4 parts. I have now represented 1/4 on the left. My next fraction that I'm comparing is 1/8. So on the right model, I will shade in one part to represent 1/8. Perfect. So now we need to compare these two fractions. First of all, I notice that both of them are unit fractions because both have a numerator of 1, which makes them a unit fraction. When we compare fractions that have the same numerator, we really need to pay attention to the denominators. I notice this denominator is 4 and this denominator is 8. So you might be thinking, well, 8 is greater than 4, so 1/8 is greater than 1/4. Lots of kids think this, but let's look at our model. I notice that 1/4 is a much bigger piece or part than 1/8. Think back to our example of sharing cookies. If only 4 kids are going to share this cookie, you will get a much bigger piece of the cookie than if you have to share with 8 kids and you only get 1/8 of the cookie. When our numerators are the same, we have to look at our denominators and think about the unit fraction. 1/4 is a greater piece with a unit fraction. So, when we compare these two models and these two fractions, we know that 1/4 is greater than 1/8. We can choose our symbol, and now we can fill in the blank to explain how we know. Our sentence stem says 1/4 is blank, 1/8 because blank. Okay, I know that I just completed the problem, and I know that 1/4 is greater than 1/8. I'm going to use my text box. I'm going to fill in using my math vocabulary. 1/4 is greater than 1/8 because, well, how do I know? Because I see that 1/4 is a bigger part of the whole than 1/8. So let's put that in our answer. 1/4 is a greater part than 1/8. Make sure today when you are recording your why, when you say your because, you are thinking about math vocabulary in your answer.
Okay, so really focusing on that math vocabulary. We are not going to use words like bigger or just because. We're going to add in vocabulary such as unit fraction, denominator, numerator, etc. Okay, please hop over to slide 4. Slide 4 is asking us to compare 3/4 and 3/3. You will notice that we have circle models that are empty. So we are going to need to complete the model. We are also going to need to complete the justification statement and comparison sentence, okay? We have worked with fractions for quite some time, so you guys know how to partition circle models by now. Our first one is 3/4. That means we're going to have 4 pieces. Go ahead and with your pen or your shapes tool, create a line going down the center. I should have used my shapes tool because that was not very close to the center. That's better. And then the same going across. Remember, when we make partitions inside of circles, we have to create these kind of half circle triangular shaped pieces. We can't just draw lines going up and down because those would not be equal sized. Okay. For the thirds, you can imagine drawing a peace sign or an upside down letter Y, or an upside letter Y, actually. Yeah, that's not very good. I'm going to redo that one. Take your line down to the center and then create that Y shape. There we go. All right. We will notice that our numerators are the same. So we're going to shade 3 parts of each model. 3 of the 1/4 pieces will be shaded. So there's 1, 2, and 3. And 3 of the 3rd pieces will be shaded. Go ahead and shade those in as well. And I'll give you a moment to get caught up on that. There's 1 1/3, 2 1/3, and 3 1/3. Hopefully you are noticing that when we have 3/3 shaded, that is all of a circle or a total whole. When we have 3/4 shaded, that is 1/4 less than a whole. We also know that 1 whole is greater than less than a whole, okay? So let's complete our comparison statement. We have 3/4 and we have 3/3. We can see that 3/4 is less than 3/3. So our comparison symbol, or that hungry alligator mouth, is open up to the 3/3 side. Okay. We are also asked here to fill in the blanks. This is where our math vocabulary comes into play. 3/4 is blank 3/3. Well, we just answered that. 3/4 is less than 3/3. Let's go ahead and add that in. 3/4 is less than 3/3. Because, and here's where we need to add that explanation. I'm going to use the math word whole because 3/3 is 1 whole and 3/4 is less than 1 whole. I got to make that a little bit longer here so we can see it. Okay. So our math vocabulary here is the word whole, the words less, and then our numerical numerators and denominators. What questions can I answer about why this is true? Okay. I am hoping in this assignment that I will start to see people not just choosing the bigger number on the bottom and saying that's bigger. Okay, that was a very common mistake that, as I shared with you last week, 9 of the 20 of you were just seeing a big denominator and saying, oh, that's my answer. And that is not true. We can see right here, 4 is a bigger number, but it is a smaller piece. So our thirds, 3 of them is the total there, okay? All right, let's take a look at slide 5. Slide 5 again is a video about working on a bar diagram or a rectangle model, and then we will solve one together. Okay, please listen and actively think about what you're seeing.
We are going to compare 3/5 and 3/8. We're going to use a bar model or a rectangle model to represent these two fractions. On the top, we're going to represent 3/1/5. On the bottom, we're going to represent 3/1/8 or 3/8. On the top model, I notice it is already partitioned for me. I have partitioned it into 5 equal parts. I know that each part is the unit fraction. 1/5, 1/5, 1/5, 1/5, and 1/5. To represent 3/1/5, I can shade in 3 unit fractions. 1/5, 2/1/5, 3/1/5. The problem asks me to compare 3/1/5 to 3/8. I notice that both of my denominators are different, which is why in my models I have them partitioned differently. In the top model, I have it partitioned into 5 equal parts. 1, 2, 3, 4, 5. But on the bottom model, it's partitioned into 8 equal parts because I'm showing 3/1/8. I know that each part of the bottom model is also a unit fraction. The unit fraction always has a numerator of 1, so my unit fraction is 1/8. After I label each part with the unit fraction, I can represent the fraction given. I'm given the fraction 3/1/8. So now I can shade, using my highlight tool, 3 unit fractions. 1, 2, 3, or 3/8. When we compare fractions with the same numerator but different denominators, we really need to look at each unit fraction. I notice that 1/5 is a bigger part than 1/8. If I think about sharing the 1 whole equally, this makes sense. If there is a pizza shared with 5 kids, each kid will get a bigger piece of pizza than if the pizza is shared with 8 kids, each kid will get a smaller slice of pizza. Even though the denominator 5 is less than 8, we really know that 1/5 is a bigger piece or part than 1/8. So when we compare 3/1/5, we see that there is more area shaded than when we shade 3/1/8. 3/5 is greater then 3 1/8.
All right. So let's go ahead and practice this. When I see this, the first thing that I'm thinking is it's going to be really annoying to have to figure out exactly where to put these partitions. So I'm not even going to use my drawing tool. I'm going to use my shapes tool and get a blue line that is as tall as one of the rectangles. That way I can duplicate it and copy and move it easily, because drawing and erasing those lines is going to be very difficult and annoying to me. So I'm just going to prevent it. Okay. So first we need 2/4. I'm going to ask you to also get a shape, that rectangle line, and to make it the size of one of the rectangles. So make it as tall as one of the rectangles. Okay. I know that fourths are 4 parts and 4 is an even number. So I'm going to start by splitting it in half. So I'm going to look at that line and put it in about the middle. Okay. I know that in order to make fourths, yes, Braden, we are on slide 6. Thanks for joining us, kiddo. In order to make fourths, I can then cut those halves in half. So I'm going to duplicate my line and move 1 over here to cut that in half. And then duplicate my line again and do the same thing on the right side. You will notice that we have only added 3 partitions. I was looking at screens and my hooligans that were working ahead were adding 4 partitions, which gives you 5 pieces. So you were working ahead and we're doing it wrong. You only need to add 3 lines, partitions, because that gives you 4 parts. Okay? All right. So now we're going to shade 2 of them. So I'm going to shade 1 1/4 and 2 1/4. Okay. So I can see that my 2/4 is about at the middle, so that seems to be the half. Now I have to create 6, and I'm going to go ahead and change the color so that it's more easy to distinguish. So now we're going to make 2 6. Again, I know that a 6 is an even number, so I can start in the middle. Okay? If I split 6 in half, that's 3 on this side and 3 on this side. So instead of duplicating once, I'm going to duplicate twice, and I'm going to make 3 pieces on the left, and I'm going to make 3 pieces on the right. So I'm going to go a little bit over on either side of the line that's up on the top model. That top model can help me see where that half would be and go on either side. So now I have 1, 2, 3 pieces. I need to duplicate my line and do the same thing over here with partitioning for the 4th, 5th, and 6th piece. So I have 1, 2, 3. Here is 4, 5, 6. Awesome. Looking at your screens, I'll give you a moment to get caught up. Thank you to my friends who started redoing this now that they've seen my model. Very good. Okay, now we've got to shade 2 of them. So I'm going to shade 1 1/6 piece and a second 1/6 piece. Visually, it's very easy to see that our purple or our 2/6 model is shorter than the shading on the 2/4 model, okay? But I need to represent that numerically and in words. So I have 2/4 and I have 2/6. We can see that 2/4 is greater, longer, bigger than 2/6. Even though 6 is a bigger denominator, we know that means it's a smaller piece. So I would rather have 2 larger pieces than 2 smaller pieces of an item that I enjoy. Okay?
Can you stay on 6 real quick?
Can I what, Justin?
Can you stay on 6? I still need to,
Yes, I can. Yes, I can. Thanks for letting me know. Now we have to think through what we're going to add as our justification statement. So we have a sentence frame here, and our sentence frame says 2/4 is blank 2/6. We can see using our symbol here that it is greater than. So we're going to use that math vocabulary. 2/4 is greater than 2/6. So excuse me, I'm going to turn off my ringer really quick for my classroom phone. There you go. So 2/4 is greater than 2/6 because, and that's where we've got to add this in here, this because. Because, and this is where we'll use that math vocabulary, because 2 1/4 pieces are larger than 2 1/6 pieces. So we've used the vocabulary of that unit fraction name for each model. We've also used the numerator and denominator that we've been given. And I'll stay here for a moment to let you get caught up. Alrighty, we have one final one before I release you to work on some, hopefully I think maybe in breakout rooms. We're going to take a look at slide 7. This is a number line, okay? This is our last model that we're going to compare fractions with. Again, it's the same concept, it just looks different visually, but we're going to follow the same procedures. Here's how we would compare fractions with the same numerator on a number line.
Let's compare these two fractions with the same numerator using a number line. I notice the numerator is both 2, but our denominators are different. I notice 1 is a 5 and 1 is a 3. So for each number line, I'm going to represent a fraction by partitioning into these parts. On the top model, I'm going to represent 2/5. On the bottom, I'm going to represent 2/3. First, I need to pay attention to my denominator and partition my number line correctly. I see that I need to cut this one into fifths, so I'm going to partition into fifths right now. My left tick mark is 0. My furthest right tick mark is 1 whole, and I have partitioned my number line into 5 equal spaces. Each one of these is a unit fraction, which is 1/5. So now I'm going to label the tick marks and count by my unit fraction. Now I have just labeled the tick marks using my unit fractions and counting on 1/5, 2/5, 3/5, 4/5. Now I can represent 2 1/5 on the number line. Starting at 0, going to jump to 1 1/5 and a second 1/5. And I'm going to plot this point right here at 2 1/5. Now I'm going to look at my second fraction, and I notice that it is partitioned. The denominator is 3, which means I need to partition into thirds. I have now partitioned into 3 equal spaces. Now I need to label my tick marks with the correct information. My tick mark to the left is 0. My tick mark all the way to the right is 1 whole. And I have labeled each tick mark using my unit fraction. I have 1/3, 2/3, counting up to 3/3 or 1 whole. Now I need to represent 2 1/3 on my number line. So I start at 0, and I'm going to count each 1/3. 1/3 plus another 1/3 is 2 1/3. I'm going to plot this point right here at the location of 2 1/3. So now we need to compare 2/5 and 2/3. I notice that both have 2 parts counted. That's why our numerator is 2. However, let's pay close attention to each unit fraction. I notice the 1/5 piece is smaller, is less than 1/3. This makes sense because in the top model, there are 5 equal parts, but in the bottom model, there's only 3. So even though 3 is less than 5, a third is a much bigger part than a fifth. This tells me that 2/3 is greater than 2/5. So let's look at our comparison. 2/5 is less than 2 1/3. Fill in the blanks and justify my answer. 2/5 is blank 2/3 because 2/5 is less than There we go. 2/5 is less than 2/3 because why? This is where we can talk about our unit fraction. 1/5 is less than 1/3, so 2/5 is less than 2/3. I know because 1/5 is less than 1/3. Move it into the blank to show my thinking.
Okay, so Miss Renele is trying to get you to that mental math place, okay? When we were comparing fractions with the same denominator, you guys were very quickly able to figure out if more pieces or less pieces was going to be greater or less than. Now all we're doing is thinking about the size of the piece and seeing if more of them or less of them is going to be the greater or lesser fraction. Let's take a look at slide 8 together. I'd like for us first to set up our 0 to 1. That is going to help us because I have to think about how large this whole number line is. If I make my 3 pieces this big, that does not use the rest of this number line, which means my whole is not the same size. Remember when we talked about that cookie at the beginning? You've got to make sure that you're using the whole number line from 0 to 1, not just the part that you want to focus on. We've got to use that whole thing, okay? For me, number lines work the same as bar models or rectangular models, and I don't like erasing a bunch of times, so I like to use this shapes tool and just slide it where I want it to be, okay? When I create 2/3, a 3 is an odd number, so I can't put it in the middle. So I'm going to move to the left of the middle, and I'm going to duplicate my line and move it over to the right of the middle. And now I can see that I have 3 pieces. Also, my pieces are about the same size. Notice one of them is not as big as my fingernail and the other one is as long as my whole finger. Okay, they're about the same size. They might not be perfect because I'm a human, not a robot, but they're pretty close. Okay, and now we're going to shade 2 of these 1/3 pieces. Okay, so we have 1/3, 2/3, and then we get to 3/3. I'm going to shade 2 of them. I'm going to shade with my highlighter 2 of these 3 pieces. There's 1, there's 2. If that's difficult for me to see on the line, I can shade again up top to make it look more like a rectangular model. And I have 2/3. And again, we know with number lines that we need a big fat dot. So I'm going to put my big fat dot on the 2/3. Okay. Let's take a look at our 6. 6 are even. There are 6 pieces, so I can start in the middle. I'm going to duplicate a line and put it in the middle. Now I've cut my 6 in half, and I know that half of 6 is 3. So I've got to create 3 pieces over here on the left side. So I need to duplicate that line twice. Go ahead and do that. I'll leave mine here so you can see. Now I need to do the same thing over here on the right side. I've got to duplicate. And there's my second piece. And here creates my 3rd piece. Okay. So we've only added 5 partitions, but that gives us 6 lines. Now I'm going to shade it. I need 2 6. So I need to get to the 2 6 mark. I'm at 1 6, 2 6, 3 6. Yes, Terrence?
Can you please slow down?
I can. Thank you for letting me know. Justin, you making this with us? And I'm going to shade 2 of these 1 6 pieces. So 1 6. Here's 2 6. And it's a number line, so we need that big fat dot. Okay. Now, Miss Renale was inviting us to think about our unit fractions. We can see that 1/3 is a larger piece than 1 6. So obviously, if I have 2 larger pieces, that's going to be more than 2 smaller pieces. So when we write this out, we know that we have 2, didn't want to be in the highlighter. We know that we have 2/3 and 2 6. And we're going to compare, which we can see that 2/3 is greater than 2 6. We can see that visually, but we can also think about the size of the unit fraction. 1/3 is a bigger piece than a 1 6, so 2 of them would be larger than 2 of the smaller 1 6 pieces. So 2/3 is blank 2 6. We know from our model and our unit fraction that 2/3 is greater than 2 6. Okay. 2/3 is greater than 2/6 because, and let's use that unit fraction knowledge. 2/3 is greater than 2/6 because 1/3 is a larger piece than 1/6. So we're using some of that mental math. By now we know the smaller the denominator, the larger the piece. Your independent work today gives you 2 of each kind of model. On slides 10 through 15, you'll find 2 number line comparisons, 2 circle model comparisons, and 2 rectangular model comparisons. You are to complete each one exactly how we did. So when it's time to work, you have the examples we did together, and you have the videos from Mrs. Renoulet explaining exactly what to do if you get confused. So you have these live views to look back at. So slides 10 through 16 are your independent work. Slide 16 is your success criteria, and again, you will explain how you feel using math vocabulary words. Okay? This is your independent work for the day.